This video will cover bonus additions and bug fixes throughout the whole Parkour series project. You can skip through to a certain mechanics section if you are only looking for select ones. This is the second to last video in the series, and the next and final one will be optimizing the project and making it more professional in terms of coding practices and methods. The first section will be on sliding additions and bug fixes. First will be an addition to make the player alignment system more accurate. Currently the player is not aligned correctly and lags at an odd angle. This is caused due to it being a looped frame from the sliding animation. Go to the Align Player to Floor macro. Delete the Set Actor Rotation. We will replace it with setting the mesh's relative rotation instead, since that is not driven by root motion. The R interp to current should be the current relative rotation. Next, break the rotator made here. Multiply pitch by -1. Make a rotator and set it. For the yaw value, get the current relative rotations yaw. Make sure to set the multiplied value to the roll and not pitch. This is since the mesh is rotated by default, so this accounts for that. It is now working smoothly. The next addition will be a simple hand IK, so the player's hand is always grounded during the slide. Go to the sequence in Trace Floor while sliding and add a pin. Add a sphere trace by channel. For the start, get the head location of the mesh. For the end, add a vector to it. Add the actor vector multiplier function, which is a function I made in the Parkour series. I will show it briefly as it is a very simple one which uses a custom enum. Set the direction to up and multiplier to -50. Duplicate it for a forward multiplier of -40 and add that as well. Set the radius to 20. I will promote the draw debug type to a variable for easier testing when needed. Promote the return value to a variable called slide hand IK found. Then break the hit result and add a vector to the location. Multiply the normal and set it to a float of value -10. You can adjust this value if needed. Promote this to a variable called slide hand IK location. Go to this timeline and add the following nodes to reset the mesh rotation. Go to the Reset XY Rotation event and set Slide Hand IK found to false after the can move. Set it to false before this delay as well. Finally, add a pin to the sequence and set it to false here as well. Now go to the animation blueprint. In Event Blueprint Update Animation, get the slide hand IK found. Make a new float variable called slide hand IK alpha. Set it to an finterp node with the current value being itself. The target should be the slide hand IK found, which will automatically convert to a float if you drag it in, where false gives 0 and true gives 1. Vth delta time is the world delta seconds and the interp speed will be 5. A higher interp speed will result in faster interpolation. Next, promote the slide hand IK location variable to a similar interp setup using the vector interpolation. Make this have a higher interp speed of something like 20. Next, go to the anim graph and duplicate one of the two bone IK nodes at the end for the right hand. The alpha is slide hand IK alpha and the effector location is the slide hand IK location. The IK is working now. You can adjust the interp speed until it looks right for you. Next will be animations for sliding under obstacles. Get sprint to backslide from Mixamo and make sure it is set to without skin. Then get corkscrew kick up. Finally, get soccer tackle. You can use any other animations you want for this as long as there is root motion. I will use the Mixamo converter to convert them to the Unreal Standard rig. Next, I will make a folder for the new animations. Import them. Bulk edit via property matrix and enable root motion for them. Create montages of all three. Add a motion warping notify that lasts from the start and ends as the player starts to get up. Change the warp target name to slide end and uncheck warp rotation. Copy and paste the notify for the other two animations. Make a new function in the character blueprint called slide under check. Add a box trace by channel. The start and end will be the actor location with a forward multiplier of 200. The half size will be 75, 75, 75. Set the orientation to the actor rotation. Add a branch using the return value. If false, add a return node with a Boolean output called slide under. This trace checks if there is an obstacle in front of the player. If true, add a capsule trace by channel. The start and end will be the same, but change the multiplier to 400. The radius and half height should be that of the capsule components. Add a branch, and if true, add a return node. This traces to check that there is space to get back up if the player was to slide under there. Next, add a sphere trace by channel. Break the previous one's vector and make it using only the X and Y components. For Z, get the mesh's world location and add 50 in the Z axis. Break the vector and set the Z axis. Set this added vector as the start and the make vector to the end. The radius will be 20. Add a branch using the return value and a return node if true. This trace checks that there is a gap to slide under by tracing from the player to the target location. If false, add a for loop. The last index should be 5. In the loop body, add a sphere trace by channel. The locations should be a forward multiplier. Add a vector with Z being -250 and set it as the start and end. For the multiplier, multiply the for loop's index by 10. Then add this to 100 and set it. The radius should be 15. Add a branch. Break the hit result and make rot from X, splitting the pin and getting the absolute value of pitch. Check if it is nearly equal to 0 with an error tolerance of 5. Make a new local Boolean variable called found irregular and set it to true if false. On completed, add a return node with slide under being not of found irregular. This final trace is done multiple times to ensure that there is a floor along the path and that it is relatively not angled. I will now comment the function. In the slide input, make space before the sequence. Add the slide under check function before it and add a branch using the output. Connect the false path to the sequence. I will make some space and add a sequence if true. In then 0, set is sliding to true and can move to false. Then get the motion warping component and add or update warp target. Split the pin and set the name to slide end, making sure it is exactly like you named it in the montages. For the location, get the actor location and add a forward multiplier of 450. Then get the mesh and play montage. For the montage to play, add a get node and make an array. Add 3 elements to it for each animation. For the index, add a random integer in range. The max should be the array length -1. This chooses a random animation to play each time for sliding under. Connect then one of the sequence to play from start of the scale capsule timeline. The animations are also pretty slow, so you can change the rate scale of them. I will change them to 1.2. It is working. Next we'll be fixing issues with jumping while sliding and other general fixes. First, go to the select nodes condition and replace it with checking if the vector 2D itself is nearly 0 not. Next, make a custom event called reset slide and connect it to the skin move after the montage. Make another one called reset slide timer, connecting it to this branch. After this clear timer, check if the continue sliding handle is valid and clear it if true. Connect it straight to this, check if the previous branch was false. Then go to the play montage for sliding under and call reset slide on blend out. Go to the reset XY rotation event and make some space. Call reset slide timer and revert capsule at the start of the event. Then delete the set actor rotation, and replace it with corresponding nodes for the mesh's relative rotation instead. Also, delete the set actor rotation at the end. Make some space after the true path and add another branch. Connect the relative rotation to it. The condition will be if the current active montage is sliding end in place. Then go to the onJump event and make some space. After the reset XY rotation, get the mesh's anim instance and montage stop. Leaving the montage empty will blend out the current one. Change the blend out time to 0.1, then get the character movement and set the jump Z velocity to something lower than the default one. I will do 500. Then add the jump node. Add a retriggerable delay of duration 0.01 and change the velocity back to the default value. This delay is so that the player jumps with the lowered one, then it resets almost immediately after. This variable is a simple one which is declared on event begin play and just gets the jump z velocity. It is working now. Here is a summary of the additions and changes. The player slides down this ramp and aligns to the surface with hand IK working. If you slide under an obstacle, a different special animation will play. The next section is for vaulting. First will be an addition to allow the player to continue moving at the same velocity once vaulting ends, as currently the player stops after landing briefly before they can move again. This is due to the root motion. To fix this, first go to the vaulting montages. Add a new notify track. Make a new notify called ignore root, adding it around the ending of the last motion warping notify. Add this for all the vaulting montages you have. For the close vault ones where the player's hand holds the vault object, add an extra notify called enable actor collision around the end of the second motion warping notify. Next, go to the animation blueprint. Add the ignore root notify. Set the root motion mode to ignore root motion for it. Then add the enable actor collision notify and set actor enable collision true for your character. Now go to the character blueprint and open the vault macro. Change the movement mode to walking at the end, then set the root motion mode of the anim instance to root motion from everything. Set the capsule component radius to the default one. I will make a new variable for the default capsule radius. The player now moves without losing velocity or freezing after vaulting ends. The next addition is for vaulting over thin objects. Get the vault over box animation from Mixamo and convert it using the converter. Set frame, height, and rotation to 0 in custom root motion for this one since we need movement in the z-axis. Import the animation. If there is no movement in the z-axis, delete the output animation and repeat the steps, then re-import and enable root motion. Make a montage of it and change the start and end times to 0.15 and 1. Add the motion warping notifies similar to the previous ones. I will also fix this error of the player floating up when the vault animations with offsets play. This is happening due to the capsule component and the animation route being around the center instead of closer to the bottom. Make a new structure called vault animation. It will have a montage variable called montage, a float variable called offset and a boolean variable called disable collision. Make a new variable of this structure type in the character blueprint. In the vault macro, delete the montage selection code as we need to instead use the structure variable to include offsets. Also delete the motion warp locations as we will promote them instead to make the blueprint cleaner. Promote each vault location to a variable. Then add a branch. Promote the vault distance to a variable as well called vault test. For the first branch, check if vault test is less than or equal 3. If true, add a branch that checks if it is only less than 3. Copy the shown nodes for the locations and animation selections. This is being set if it is a thin object and the middle will instead be an average of the start and land. Then set the vault animation montage and split the pin. The montage should be vault over box, the offset should be 40 and set disable collision to true. If this other branch is false, set vault animation montage and connect it to the rest of the code. Copy the code for the selection. It is the same as the previous one but uses the struct variable instead. Copy the following nodes for the motion warp locations. Make some space before the play montage. Set actor enable collision to not of the disable collision variable from the struct. Then reduce the capsule radius to 10. The collision is disabled only for those vaulting with hand animations, and since they have an offset they will be moved down to be more accurate. Make sure to set the montage in play montage as well. The vault offsets are working now. Vaulting over thin objects is working as well. The animation isn't perfect, so you can replace it if you want. You can also adjust the play rate to your liking. Next will be a bug fix to ensure you cannot vault over tall objects. Go to the vault trace function. Copy this code for the uncompleted of the loop. It simply checks the difference in Z of the vault target position and player, ensuring it is not too large. Go back to the main graph. Add a branch before the vault trace that checks no montage is currently playing. This is for spam prevention. Vaulting over thin objects works. The player can move without losing velocity after vaulting ends. Next will be mantling additions and fixes. Currently the same animation plays for mantling regardless of the object height, so we will add a second one for taller ones. I will use the sprint to wall climb animation from Mixamo. Convert it with frame, height, and rotation being 0. Import it, enable root motion and create a montage of it. Change the start time in the montage to 0.15. Then duplicate the motion warping notify from the previous mantle montage and adjust it as needed. For this one, add an extra one at the start until the beginning of the second one called mantle extra point. Then go to the mantle macro in the character blueprint. Duplicate the add or update warp target for the extra point. Set the location to the same as the other one but subtract 50 from Z. Drag out of location 2 and copy the code to check the height difference. If falling, the player will play the default mantle animation regardless of height. Add a select node and connect the condition. If true, it is the regular mantle, if false then the sprint to climb one. It is working. Next I will change the control for the wall run climb mechanic as it aligns more with mantling. This is a very simple change. Cut the graph from the jump input. Paste it in the false path of this branch. Also change the initial trace length to 150. Finally, add the montage playing check to mantling as well. The wall run to climb now works with the same input as mantling if the object is tall enough. Here is a showcase of the updates for mantling. Next will be for the sprinting mechanic. This only has bug fixes, with the first one being this error where the run to stop keeps playing if you stop once then move just a bit. This is happening since we are using the triggered seconds to calculate the sprint held time, which keeps increasing, so it will be above the required threshold after the first time. Go to the sprinting code. Make a new float variable called sprint held time. Set it to the current value of it with the world delta seconds added to it in the sequence. This increases it in real time as it is being called untriggered. Add a pin to the sequence and set the held time to 0. Remove this reroute for the greater than and replace it with sprint held time. Set it to 0 after the run to stop play montage as well. This error is now fixed. The next bug will be stopping the run to stop animation where required. Open the montage for it and add a montage notify called enable interrupt. Position it where you want the player to be able to start moving again. At the end of the play montage, add a set timer by event and make a custom event for it called run stop timer. Set the time to 0.01 and looping to true. Promote the return value to a variable. Add a branch in the event that checks if falling or if the last movement input vector is not nearly equal 0. If true, add a branch and make a new Boolean variable called can interrupt run stop for the condition. Set it to true on notify begin and false on blend out. If the branch is true, add a montage stop using the anim instance. The montage should be run to stop and set blend out time to 0.15. Then add another branch. Connect the blend out path to this as well. This branch checks if the run to stop timer handle is valid and clears it if true. This check stops the run to stop montage if the player tries to move or is falling and it can be interrupted. The sprinting system has no bugs now. Next is beam walking. First is an addition which allows for custom meshes to be used by the beam. To add this, first open the beam actor. Remove the set material and material variable. Instead set the static mesh and promote it to a variable. Set instance editable to true. Set the default value of it to the default beam 1. Then set the start and end scale. Split the pin and promote it to a variable called mesh scale. Set both X and Y components to this. Also make it instance editable. Go to the Add Spline Mesh component and make a transform. Split the location pin and promote Z to a variable called Z offset. This allows for the spline to have an offset as the meshes you add will not have the same pivot points. This should also be instance editable. I can now add custom meshes. Since it is too big, I can also change the mesh scale easily and it will update along the spline. I can increase the mesh length so it creates each spline mesh at the correct points as well. The spline is not on the surface of the mesh so it can be corrected easily using the Z offset value. The beam walking mechanic works perfectly with the custom mesh as well. The next addition will be making the beam have a constant spline point type if you want. In the construction script, add a for loop. Set the last index to the number of spline points -1. In the loop body, set spline point type and the point index should be the loop index. Promote type to a variable called spline type that is instance editable. I can easily change these beams now to be uniformly linear or curved if I want. There is this one error with the system where the tangents can't be modified if you set all points in the construction script. To fix this, you can add a boolean that controls if all spline points should be the same or not. If you want the tangents to be movable, then leave the variable unchecked for those beams. The tangent can now be modified after setting the variable to true. Finally, there is a very quick bug fix to make the exit beam work better. Simply change the trace length in the exit beam trace function to 70. You can now add any mesh you want for the beams and can control the point types more easily. Next will be ledge climbing, which will only have bug fixes. First is this issue with trying to hang while climbing up, as there is no spam prevention. Before fixing this, I will move the on jump and on walking off ledge events to the main event graph, as it should be a general event. Then go to the hang on ledge macro. Add a branch at the start that continues the code only if the current active montage is not the climbing up one. Also add a branch that checks if wall climbing is false, so we can't ledge climb while wall climbing. The player can't hang while climbing now. Next is fixing issues with the use-only climbable ledge system. Currently the player can detect ledges through walls. First go to this play montage and set actor enable collision to true after it. Then go to the trace ledge function and copy the shown nodes. This new check will only check for climbable ledges after tracing, as currently it was on the ledge trace channel, which means the trace itself was ignoring any other ones, which is why it could be detected through walls. Finally, we will make the drop to ledge more accurate. Go to the drop from ledge function and change the values shown here to 175. Then go to the drop from ledge component and only continue the code if no montage is currently playing. Then add a sequence and rearrange the nodes as shown. This is since we want the move component to happen while the animation is playing. That is all for ledge climbing. Next will be cover. First we'll be adding enter cover animations. Currently it just moves and rotates and there is only an animation for exiting. Get both stand to cover animations from Mixamo. One is for standing to cover stand and the other is for crouched. In the Mixamo converter, for both set the height and rotation to 0 at frame 0. Then set the height to 0 and rotation to 180 for frame 34 of the stand to cover stand and frame 38 for stand to cover crouch. This is to adjust the root bone rotation so it aligns properly with the wall. I will make a new folder for these animations and import them. Enable root motion for both and create montages of them. Add a motion warping notify to them called cover lock which ends just as the transition does. Then go to the cover input part in the character blueprint. After the branch here, call the cover trace crouch function then open it. Delete the mesh world location. Make a new vector input called trace initial location and connect it to this add vector. Also make this value to multiply by an input called forward amount with a default value of -30. For this one, the location should be the mesh's world location and change the forward amount to 70. The amount is different here since this is being done before the player is actually in cover, so the offset should be forward for this trace. Then delete the move component too. Add or update warp target and set the name to cover lock. Set the location and rotation to the ones that were being used for the move component too. Then get the mesh and play montage. Add a select node for the montage which checks the output of the cover trace crouch function. If false, it should be stand to cover, and if true, then stand to cover crouch. Connect on blend out to the rest of the code. Add a branch using should crouch at the end that crouches if true and uncrouches if false. For this cover trace crouch, set the location to the mesh's world location as well. Swap the select node montages as I did it incorrectly. The player now plays a regular stand to cover animation here. If the target object is shorter, it plays stand to cover crouch instead. Next we'll be adding crouched cover to cover animations. Currently if the player is going from cover to cover but it is to a shorter object, the animation is still the same. Before we start, go to this part in the cover graph and add the mesh's world location for the input. When we cover to cover here, the player crouches and floats in the air and it does not work properly. Go to Mixamo and get this crouch cover to cover animation. Check mirror and download it again for the other side. Use the Mixamo converter on it. Import them and enable root motion for them. I will also rename the animations for left and right. Then make montages of each and copy the motion warping notify for them. Go to the cover to cover input part, which I used left control for, and make some space. Add the cover trace crouch function and copy the nodes for the trace initial location. This traces at the target move to location. Then add a sequence with a branch that crouches or uncrouches based on the return value. This code sets the player as crouched or not prior to the animation playing. Add a select node for the montages to play and add the following ones. Call stop cover update after the set cover state idle. Then call cover update trace before the forward trace function. Swap the select condition montages as shown as it was incorrect. It now plays different animations for standing and crouched cover to cover. I will now do some general bug fixes. First, my timeline got broken for the camera offsets. You can skip this if yours is fine, otherwise simply add a track that goes from 0 to 1 over the duration of 0.2. Before setting the render opacity here, add an is valid of the cover HUD. Open the move in cover function and add a branch after this line trace, which I forgot to do in the original video. Next is a bug where the player can continue moving in cover even if there is no ground. To fix this, go back to the move in cover function. Make some space before the last node in the uncompleted. Add a sphere trace by channel and add the following nodes. This trace simply checks from the target location vertically down to check if there is a floor and only moves if true. The player can't move anymore here since there is no ground. Next is this bug that allows us to jump while in cover, which should not happen. First, go to the exit input in the cover code. Make a custom event called exit cover and connect it to the code. Call the event at the end of the unjumped and unwalking off ledge events. Then go to the unjump event and add a branch that checks if cover is false after this one. Now jumping doesn't work while in cover. Next is a quick bug fix that where the turn in cover is not working 100% accurately. Go to the cover switch direction macro. Connect this to the stop cover update function as well. Finally, select the camera boom. Check enable camera lag. Set the camera lag speed to 25 and the max distance to 20. This is so the camera does not snap immediately when transitioning from crouched and uncrouched. Enter animations work now for cover to stand and cover to stand crouch. The system also decides whether to play cover to cover standing or crouched based on the height of the target object. Next are bug fixes for wall running and sliding. First, we'll be making the hand IK smoother. Go to the animation blueprint and to the wall run variables. For the hand IK locations, add AV interp node setup. Make the interp speed something higher like 30. Do this for both location variables. It is smoother now. The next fix is to prevent wall running on objects that are not tall enough. Go to the OnCapsule component hit code. Make some space after this trace. Add a sphere trace by channel and copy the following nodes. This checks in the direction the player is trying to wall run and checks that it is tall enough by tracing higher up to the player. Finally, go to this part for wall slide and change the Z value to 110. That is all for this section. Next is bug fixes for wall climbing. The aligning system is working, but the values I used are not the best, as here the player rotates too much and it looks unrealistic. Go to the Enter Wall Climb input part and make some space. We will first prevent wall climbing while ledge climbing by using a simple branch. Then go to the wall climb rotation function. Change this multiplier value to 100. Then add a pin and add an up multiplier of -20. Do the same for the second trace, but change the up multiplier to 10. Finally, go to the wall climb spine correction function and lower the outrange B here to 15. It is looking better now. Next is double jump and land bug fixes. Most of the fixes here are integration issues. If the player wall runs after double jumping, the animation is stuck in the double jump one for the initial wall jump as well. To fix this, go to the wall run on landed event and make some space. Make a new Boolean variable called force default jump animation and set it to false here. Go to the end of the capsule component, hit and set can wall run double jump to false. Then set force default jump animation to false as well. Delete the same nodes from the wall sliding path and connect it to the other one. Then go to the wall jump input macro and set it to true after wall jumping. Set it to false here and also call reset air dash. Connect this other path to it too. Then go to the animation blueprint. I will quickly organize the graph. Promote the force default jump animation variable here. Go to the fall loop state and add an and condition that checks if force default jump animation is false. Go back to the wall jump input macro and rearrange the nodes as shown. The animation errors are fixed now. Next is a bug fix for roll dodge dash. There is only one very quick one. The player can move and rotate while the land to roll animation is playing. To fix this, go to the air dash landed event. Remove this path from false. Then go to the on jump event and call reset air dash before this branch. That is all for the fix. Next is the final section, which is for predictive movement. The first addition will be different idle animations based on the thickness of the animation. Currently it is the same idle animation and it can look unrealistic when you land on smaller objects as shown. I will get this idle animation from Mixamo where the feet are closer together for thin object idle. Convert it using the Mixamo converter. Import the animation. Then open the movable object blueprint interface. Add a function called isThinObject that returns a Boolean variable. Go to the movable object blueprint and open the function. Promote the return value to a variable called thin object and set it to instance editable. This lets us easily change if an object is thin or not in the editor or child blueprint. Do the same for the beam actor as it implements this interface as well. Set the default value of this one to true as most beams will be thin anyway. Next, go to the predictive move code and to the current point trace event. Get the isThin object function from the current closest actor and promote it to a variable called predictive move thin object. Then go to the animation blueprint. Promote on predictive point and predictive move thin object here. Go to the idle state. Copy the following blend by bool setup. You can change the animation in the false pose if you want it to be different to the default idle one. I will now select these jumpable points and set them as thin objects to test the addition. The animation is now different for these points. Next will be a bug fix where the player jumps to beam actors from a further distance when it should walk to it regularly unless there is a gap and no floor. To fix this, go to the predictive move has gap function. Remove this code that finds the average actor location. Replace it with a vector average that instead uses the land position of the closest predictive actor. It didn't work before as it was finding the average of the actor and the beam actor's origin was not always the closest position to the player. Then go to the end and rearrange the nodes as shown. Add the following nodes. This does a more accurate check on the distance thresholds based on if it was a beam actor or not. Now the player does not predictive move to this beam and instead walks onto it as usual. They will predictive move to this other beam, however, since there is a gap and can't be walked onto naturally. The final bug fix is that the player predictive moves to exit the beam even when they can just walk off regularly. To fix this, go to the beam walking code. Before this predictive move event call, add an exit predictive move trace. Copy the following nodes for the start-end location input. Add a branch using the found output and connect it to the predictive move event if false. If true, call reset predictive move, reset predictive do once and set on predictive point to false. This disables predictive movement and allows the player to walk off as usual. The player now has different idle animations based on the thickness of the object, which can be manually set by the user. There are also no bugs with the beam walking system in relation to the predictive movement one. That was all the additions and fixes. The next video will be the final one in the series, which will cover optimizing the project and tying it all together. You can purchase the whole completed project files using the link in the description if you want. That is all for this video. If you enjoyed, like and subscribe for more content. Thanks for watching.